You think I gave you what? Did I do something wrong, Elijah? No. Ben? Did you wait? Somebody had who was the question I asked? Grayson, what
was
was
number 17?
17 is 2/3. Oh.
What's 3?
3 is 4/9. L.
What was 12?
12 was 20. Lex.
What was 18?
18 is 4/5. Maddie. I will answers first though. David.
Oh, what was number 4?
4 was 54 miles per hour. James. What was number 2? Number 2, as I have it, is 0.29. 0.29 meters. Ben.
What was number 8?
Number 8, I have 64 degrees. 64 degrees. Now 7th grade, as I mention every time, ladies and gentlemen, in 7th grade, it's imperative, ladies and gentlemen, that I would, if I were you, get yourself a blank piece of homework paper. Again, it's just a good way to organize your notes. So if you have, let's say there's something on problem number 5 you want to remind yourself, you can put it in box 5 and say, hey, make sure you multiply here or divide, or here's the formula that goes here, or this is what you need to do here. Just, you know, teach yourself, train yourself to be good note takers and know what your strengths and weaknesses are. Okay.
I didn't get number 1.
Well, I got number 4 on the table first. Or somebody asked me about problem number 4 first. Sam?
What was number 6 and 12?
6 was less than and 12 was 20. Maddie, which one was it?
4.
Number 4. That is ginormous. Number 4. So if you had issues with number 4, this would be the notes. Norton started driving at 9 in the morning. By noon, he had traveled 162 miles. Again, I strongly encourage you, you know, if you kind of draw this out. He started at 9 a.m. and he stopped at noon. And he went 162 miles. So when we talk about average speed, we're talking about miles per hour. How far did he go every hour? Well, first thing you need to do is figure out how many hours he drove for. From 9 o'clock till noon is how many hours? 3. So the gist is, if you divide, you know, you're driving a total of 162 miles in 3 hours, that's a division problem, because that's what averages the total divided by how many. So if you take 162 and divide it by 3, which, by the way, let me also throw this at you. Speed, his average speed is in miles per hour. The word per, ladies and gentlemen, is a
Percent?
It's a division sign. It's dividing by. So it looks like this: miles divided by hours. And that's what we did. His miles was 162. I am now going to divide it by hours. That's where this comes from. 3 goes into 16 5 times. That's 15. And then boom. So there is your miles per hour. He goes 54 mph, miles per every hour. 54 miles per hour. Now where was it? Somebody asked me a second. Ben, what was it? Jax.
I don't get how I got 2 wrong.
Number 2, ladies and gentlemen. Oh, wait, there's more stuff here? Is there more 2? Where does 2 start? Oh, for crying out loud. Maybe I need to be just a little smaller. Simon ran around and jumped 3 times. The length of his jumps are shown. His longest jump was how much longer than his shortest jump? So you're looking for difference between the longest. The difference is what type of problem? Subtraction. Which one of these is his longest jump?
4.27.
And you're subtracting his shortest jump.
3.38.
You did that and didn't get the right number?
I got 0.39.
Well, let's look. You borrow from the 2, it becomes a 1. This is a 17. That's definitely a 9. You can't take 9 from 1, so you borrow from this, it's a 3. That becomes an 11. 9 from 11, every time I've done it, Jax, it's 2. And the decimal goes right there, 0.29. So God bless you, yours was just a subtraction issue, or what?
Yeah.
Ben Moon.
How do you do number 12?
And that would be Jack's where I write in my notes. Make sure you do this one a couple times so you make sure you get it right.
I got 10.
You did get 10.
Same, I got him too.
I got 10 too.
Wait, let me check. What number?
I got 12.
12.
That's 20. Let's look at it. Here we go.
No, that one's 12.
Order of operations. You know the last thing you're going to do is take 20 minus whatever you get in this bracket here. Because brackets, order of operations say you have to do all the grouping symbols first. So that gets done first. So here we go. It's going to get 20 minus, there's a bracket here, 10 minus 5, because the first thing in order of operations, I have to do grouping symbols inside of grouping symbols. So 3 minus 1 is 2, right?
2, yeah.
Now the next thing I'd have to do is the multiplication inside the grouping symbols. So I still have my 20 minus my bracket here. 10 minus, what's 5 times 2? 10. Then I'd have to do my subtracting inside the bracket. What is 10 minus 10?
0.
And 20 minus 0, every time I've done it, would be 20. I'm not sure. Where did you, and again, maybe you went wrong here because you probably did 10 minus 5 first, which you can't do because that's subtraction before
I
multiplication.
added the 3 and the 1 and then did everything else.
What?
See, I accidentally added the 3
Oh,
and the
well
1, I
that,
got
you did,
4.
yeah, well, if you add the 3 and the 1, you're gonna go wrong
Yeah.
instead of subtraction. Yeah.
And you get how I got 11.
Was,
Wait, no.
Yeah, I know.
11. Alright, in 7th grade, everybody take a gander here because you might as well get used to this because these type of problems are going to come up on a regular basis. You're finding, first of all, perimeter, so don't get it mixed up with area. They're not asking you for the area. What is perimeter? Adding all the sides, right? And you don't know this side. Big fat question mark there. Okay? Here's the thing that should pop into your head. Anytime you don't know the side of a right triangle, you don't know the side of a right triangle, you should be thinking Pythagorean Theorem. Okay, because you can't just guess on what this is. Guessing is not a mathematical thing, which means tomorrow, if I were you, I'd probably take my triples notes because you really want to hope that whatever you have is a Pythagorean triple. So the first thing, Amelia, you look and say, the two legs of the triangle, the two short ones, is there a 6/8 triple up here? There isn't one. There's no 6 and 8s in that first column. So if that's not the case, then you have to hope that this is a bigger triangle of a smaller Pythagorean triple, which depends on this. You look at the two numbers you're given and you say, do they have a common factor that I could shrink them by? What number goes into both 6 and 8? 3 doesn't go into 8. 2. I can cut them both in half. And if I cut them both in half, this becomes a 4,
So 3
and this becomes a 3. And you hope that this new triangle I made is a Pythagorean triple. And if you look over here, it is. It's a 3, 4, 5 triangle. That's still not what you want because that's the hypotenuse of the small ratio triangle. You now have to blow it back up to where it was when it was the big one, which goes by this. If you cut it in half to get it to its small one, you have to double it to go back to what
So
it
10.
should be. Yeah, so it'll be 10. So now you add the 10 plus the 8 plus the 6, and that's going to be the perimeter of the big triangle. You might as well get used to it because I can tell you on every test and just about every assignment from here on in some way they'll give you a Pythagorean Theorem problem, which 90% of the time you'll be able to do this. Every once in a while they'll throw something hard at you, but it's pretty rare. Jake?
Number 1.
Back. Number 1. The number of students in 4 classrooms is 28, 30, 31. What is the mean? And the note for myself here, Jake, is the word mean is what?
Average.
And did you find the average and didn't get it? Which means you add 28 plus 30 plus 31 plus 31.
Oh, I didn't know there were 3 31s.
Yeah. 4 31s, which gives you 0.6, 120 total. There's four numbers there. So 120 divided by 4, you get an average of 30. And there'd be the note, Jake, I'd write myself on my little piece of paper and say, make sure you add it, because maybe there's only 3 tomorrow. Don't say there's 4. Don't tell you, just say make sure I look closely at how many numbers there are. We're still not on that one. I was thinking somebody was going to have somewhere along the line. But I'm checking with Ben, because he's got the red, white, and blue shoes on and the red, white, and blue gator. That is quite the, is it red, white, blue day?
I don't know, I just picked a random mask.
A random math.
Back to 11.
Oh, sorry.
I just multiplied 8 and 6 and I split that in half. For real.
Ben, I'm gonna tell you, blind luck. It ain't gonna work again. Sure, why not? But why does that even make sense? That 8 times 6 is 48 cut in half would be, I mean, they just, Ben,
That's
it
what
happened to me
I
that
did
time. You will get it wrong the next time.
That's how I got it right, because I just times it
I mean,
and divided by 2.
Count your little blessings on that, because it ain't gonna happen again. That's not the way you do it. London.
I'm confused on how I got 10 right. I got 4 down.
Yeah, I'm gonna go with number 10 as well. Let's look at number 10, and I want to make sure, because I know I helped people do this one.
Yeah.
Yeah, I think people that brought the triangle up to me just graphed it wrong. So here's what number 10 should look like. Let me go down here. And I will draw it. You again should use your nice little squares. I think I can muddle my way through it here. I could actually grab the thing there. So 0, 0 is right here. 0, 3, 1, 2, 3 is right there. And 3, 1, 2, 3. Oh wait, I'm thinking this is a typo in the book because I wouldn't expect them to do this for you because this is 1, 2, 3, 4. Okay, so your triangle looks like this.
Yeah, that's how mine is. That's how mine
And if you did not get that, your triangle is wrong, but I'm thinking the book has one of these. I don't think the book would ask you to do this because we haven't done this and it's pretty tough for a 7th grader to figure out. But this is how this problem should be done. Okay? This is how it should be done. The next step, they asked you for the area of it, correct?
Yeah.
Which would mean you would write down the formula for the area of a triangle, and that is
1/2 base times.
area equals 1/2 base times height. And with triangles, base and height have to be right angles. And if you look at this triangle, nothing that you are giving there is a right angle. Okay? But the nice thing is you have a whole grid system. What color am I on? I'm going to change my colors. Change my colors. So here is that, and there's this. I kind of missed my dot. I really want to move this dot over because I kind of drifted. I should have gone up here a little bit more. Which means this line should be a little bit, I just want to draw it a little. I really should have done this on it. That wasn't what I wanted. I wanted this one. I wanted this one. You know what? I'm gonna grab a piece of real paper here and do this so you can see it. I don't want to mess you up because you didn't quite get what I was. Through the swiftness of man and the multiple of files that seem to be showing up here. Sacks and anyway. Homework paper, just so you, oh, that's how large, I guess it doesn't matter. Okay, so here we go. Don't worry, you got all the time in the world. If you finish early, you know you have an assignment, so.
Oh, take your time.
That's what I was thinking you'd say. So here I'm going to take a pic of this. And I'm going to blow it up. Because you really, if you're doing it, you should really just use the crosshairs that you've got there. Wait, why did this, sorry. I'm going to get there eventually. All right, so here it is. Everybody see it? Oh,
Yeah.
because I'm so
Yeah.
big. So I'm so big here. A little smaller, a little smaller, a little smaller. So here you go. Let's do those coordinates again. I'm going to call this my x and y axis here. First coordinate was 0, 0, right?
Yeah.
Yeah.
Yes, that was 0, 0. My second coordinate was 0, 3, right?
Yeah.
I have that right. And my fourth coordinate was 3, 4. Here's 3, 1, 2, 3, 4. Okay, so there is my triangle. Let's draw this, let's go black. So this goes from here to here, this goes from there to there, and this goes from there to there. Try to get this straight. It doesn't like that right there. Okay, so here's the deal. This is where I was at, and I said I didn't want to confuse you there. Okay, so you should have written down the formula for a triangle. Area is 1/2 base times height. The base and the height have to form right angles, and there are no right angles there. But the nice thing is a grid is all full of right angles, and you can make your own base and height using those grid angles. That doesn't change the things. In other words, look for the one line that's actually on one of the straight lines. Everything else kind of goes in the middle of all this. If you take this line and extend it just a touch up, and you take this dot and extend it a touch down, you can make for yourself your right angle base and height. Okay? So what is that right angle base and height? Well, what two lines form it? It is formed by this line and that line there. And what is this line right here?
3?
It's 4.
No, well this
4.
one should be 3,
Oh, wait.
and this one here is 3 as well. Is it not? The line from 1, 2, 3, from there to there? So the formula should be area equals 1/2 3 times 3, which is half of 9, which is where I got 4.5. And I disagree. If you look at this, those of you that got 6, there is no way in the world that you could ever get 6 total squares out of that, no matter how you did. You don't need, I mean, this is close to 1. This probably would give you 1 square. This one right here is 2 squares. Maybe this piece and this piece would give you 3 full squares, and these two probably put together would give you a 4th square. You know, and maybe a half based on whatever's left there. But there's no way you're ever going to get 6. So I'm thinking this, kids. I probably should. I'll remind me when I go back to my desk and look at tomorrow's test. I am thinking that the book meant for this dimension to be 0, 4. I'm thinking the book had a typo. They wanted this dimension in here, and there would have been your 2 right angles, which would have given you a 3x4 triangle, which cut in half would be 12 cut in half, which would give you 6. I am saying the book made a mistake in both their answer. Wait,
No.
in their answer and what they gave you. I should look right now. Do I have to look? I'll look. If it's something bizarre, I might just not count it. I'll look and see if it's doable. But there's no way what they gave you comes out to what they said. I'm going to overrule the book. Why? Because I can. Other questions? Caleb?
You do 19.
I would love to do something other than that last one. All right. Is this the one, Caleb?
Yeah.
So, ladies and gentlemen, problem number 19. A fraction line is a grouping symbol, and when you see fraction lines, you need to think about this as being all put together. You don't divide by 2 until you put these two together. So it is 2.4 minus 0.24, lining up your decimals. Divide or borrow, you get 6, 1, you get 2.16 on top when all the smoke clears. And then that is being divided by 2. So if you divide 2 into 2.16, bring the decimal up. 2 goes into 2 ones. It doesn't go into 21 or 1. So you have to put a 0 there. And how many times is 2 going to 16? 8 times.
I just got 0.8. I didn't.
Yep. After that decimal, if it doesn't go into it, you have to put a 0.
Yeah.
Take that placeholder.
I got that great.
Oh, Grayson. Billy?
I don't get 3.
Which one?
3?
There be 12 girls and 15 boys in the classroom, whether the fraction of the students are girls. And here again, this would be the note I'd write to myself because somebody had this problem on something before. What is the fraction they want? They want what fraction of
12 over
the students are girls. What fraction are girls, not the ratio of girls to boys, but what fraction of the students, girls over total number of students. How many girls are there? 12. How many students are there in the class? 12 plus 15 is 27 students. If they wanted the ratio of girls to boys, then it'd be 12 over 15, but they wanted ratio of girls to students, which is 12 over 27, and you still need to reduce. Divide both by 3, you get 4/9 of the students are girls.
Oh, thank you.
There's another note, Grayson. See, look, we've already raised your grade by exponentially. Ava,
Can we do number 5?
there's an outside chance. Probably
Can you just do all of them?
Well, I should have done that as well. But I like to do the ones people have questions on first, in case they start zoning out. Ava, what property, anytime you see a number next to a parenthesis with a bunch of stuff in it, what property we have to do to figure this out? Ends with a D, and starts with a D and ends with an distributive? Right. So you are just taking, that's what expand means. Expand means the distributive property. That just means you're taking this 3 and you are distributing or passing it out or making it times each one of those terms inside that parenthesis. What is 3 times x? It's just 3x. What is 3 times 4? But 12. When you do the distributive property, and you can't put those together, you're just getting rid of some parentheses. That's all you kind of do. The reverse of that, if you're taking something out, it's called factoring, which would mean you would start with this. If you're factoring, you start with this and end up with this. If you're doing expanding, you start with that and end up with that. Maddie, hi. Number 16, kids. So you're just asking so you don't have homework tomorrow?
No.
No.
What name is it? Oh, look. And this was one of those where you solved by inspection, by just looking at it. I would say if that inspection thing gives you a question, you can't say, 1 minus what is 2/5. Back in 5th and 6th grade, if there was a missing number problem, remember what I said to do? Think of an Maddie, just give me any easy subtraction problem you know. Is what? 3 minus 1 is 2, right? So I am missing the middle, Maddie. See, I'm missing, this is x is the middle number. So the question you ask yourself, if you have 3 and 2, if I was missing the middle on the one I knew, what do I do with 3 and 2 to get 1? Subtract, and that's what you're going to do here. You subtracted the 2 from the 3, so I'm going to take the 2/5 away from 1. What is 1 minus 2/5? Well, you need to make 1 a fraction, so it ends up being 5/5. And 2/5 for 5/5 would be 3/5. That is kind of a tougher problem. Or think about it in terms of pizza. You know, you had a whole pizza. Somebody ate something and you had 2/5 of it left. You had 2 out of the 5 pieces of the pizza left. How many pieces did somebody have to eat? 3 of them. 3 of the 5 pieces were eaten. Is it better with pizza? Does food make more sense? Caitlin,
Can you give it please?
look at this. Sure, you guys always pick the ones that are the farthest away from the ones that I just did, don't you?
Yep.
You knew it was down here somewhere in the promised land.
Thomas Land.
Oh, another inspection one. Now, this one you should be able to do by looking at it.
Yeah.
Okay, and here's the deal. All right, here's the deal. Always, always, always cover up the number that has the variable or the letter in it first. In other words, say to yourself, what number when I add 10 to it gives me 50?
40.
40. So you know this has to be 40. And then you would go 2 times what number gives me 40? 2 times what gives me 40? 20.
Oh, that's so much simpler.
Well, Grayson, these are the same things we've been doing, man. The rules haven't changed. That's what we've been doing. Maybe Grayson hasn't been listening, but that's what we've been doing. It is always easier than not. Jax,
I don't get I got 20 wrong.
it'll be better tomorrow. Ben gets it. Thank you, Ben. You can explain that to the other guys. I don't even know what number 20 is. Wait, where did 20 go?
Other paper, I think.
Why is it not match up? What did you get for an answer, can I ask?
1.44.
So, here, I'm going to tell you right now, and Jackson, we'll figure this out here. Did you write it out, 0.12 times 0.12? And this was 24, 0, 12. I agree, you get 1, a 4, and a 4. But what I don't agree with is your decimal placement, because how many decimals are in this one? 2. How many decimals are in this one? That's a grand total of 4. You have to have 4 digits after the decimal in this one, which means always start here and count back. Here's 1 place, 2 place, 3 place, 4 place. You're going to have to add a 0 to take up because there needs to be 4 digits after the decimal, just like there's 4 digits after the decimal up there. Ooh, we are getting close to doing them all. And yet we still have 15 minutes, or 10, 8, 9. Maddie Highland,
For 15.
your shirt should say Sky Highland. Wouldn't that be more fun? Sorry, what?
For 15, I did it a different way and I still got it right. Does it?
Well, my motto is this, ladies and gentlemen. If you've got a different way and it works for you, use it. However, don't do it your different way and then say I don't understand how to do it my different way without doing it my way. I mean, there are more than one ways to do all this. My brain doesn't think like all of your brains all the time. If you got a better way, a different way, as long as it works for everything. I mean, Ben could say that with this little, I multiplied the 2 sides of the triangle together, that was his different way. It's not going to work again. But if your way is working for everything, then do it. Grayson?
Number 8.
I assume that's over here, and up here. What? Oh, I have to look at that whole thing, don't I? I'm going to actually subtract this a little bit. What is the measure of angle A? And the note for problem number 8, ladies and gentlemen, is all triangles add up to, let me get this in big numbers for you, 180 degrees. When you add all of the inside angles of a triangle together, you get 180
That makes more sense.
degrees.
Now I know what to do.
Yeah, me too.
I just.
These are not hidden secrets that I keep hidden until this point. They are things we write down, whatever. So you're going to add those two together.
Yeah, and then subtract 20.
116, 180 from 116. What do you want, 74 or whatever it is?
Thank you.
Grayson, I really like the energy we bring to class today. What happened? Did you get extra sleep or have a good
I got less
breakfast?
sleep today.
Did somebody tell you if you don't do well on this test, you're not playing hockey? Where did you go with this? Anything?
James is never mind.
Jake?
Number 9. Yeah, let's do it.
We're almost done.
Classify this show. Triangle by what? By its sides? Oh, classify by its sides. And there, ladies and gentlemen, number 9 said to classify this by its sides. I don't know. I would write down the different, first of all, I would write down the different classifications by triangles for sides because you never know what tomorrow is going to bring. But when you classify a triangle by its sides, you only have 3 options. You have the option where there are no sides equal. That's scalene. No equal sides. You have the option where 2 sides are equal, and that's isosceles. And the way you know that 2 sides are equal is they give you these handy dandy little hash marks there. There's only hash marks on that side. If by chance tomorrow's had all 3 sides had hash marks, that means all sides are equal. That is an equilateral one. And that should be in your notes already. This is not anything big. Now, something special to note since you're all paying attention here. An equilateral triangle You have no choice, but every angle has to be 60 degrees. That's, no matter what, how big or small the equilateral triangle is, every angle will be 60 degrees. In an isosceles triangle, the only thing that you know is this, that the angles that are opposite the equal sides are equal. And that's another way you knew this was isosceles, is because if both of these angles are 58, the sides opposite them are also equal. If these two angles are equal, those angles are
I
equal.
just knew that because
Don't just say I looked at it, because you can't do that now.
no, I remember the hash marks.
If it was asking you by its angles, this triangle would be a what?
A cube.
Cube.
Isosceles.
No, angles are, the only choices with angles are, they're all acute angles, or they have one obtuse angle, or they have one right angle. Either right triangle, obtuse triangle, or acute triangle. James?
So 19, I do not see how I got it wrong.
Didn't we do 19 already?
Yeah.
I might have forgotten.
What?
You weren't there when I did it, or what, sir?
Well, hold on, let me look at that for a second.
He doesn't pay attention.
I don't.
Well, then, unfortunately,
I thought you said you would change.
have you ever heard the phrase, the pot calling the kettle black? Look it up.
I'm taking really good notes.
Yeah, I would just said that.
I heard it. Have you heard it? Pot calling the kettle black?
Look at my notes.
What did that turn into?
What?
James, to give you the short, you have to do this first. 2.4 minus 0.2 is 2.16.
Why is that 4 turn into 3?
What?
Why is that 4 turn into 3?
I can't hear you.
Why did 4 turn into a 3?
What for? Because I had to borrow from it. 4, you can't take 4 away from 0, so you have to borrow from it. It becomes a 3, that becomes a 10.
That makes sense, thank you.
A lot of light bulbs have come on today, it seems. Jax?
Can you do number?
You have a heightened sense of smell now, James?
I used to not be able to tell that one. I'm getting better. No.
Alright, problem number 14, Jax. This is the deal with 14. First thing you should do, this is your formula, and they tell you what B is and they tell you what H is. You should put parentheses. James, could you stop, please?
Yeah.
Thank you. You should put parentheses for both of those letters, B and H, and then you just plug the numbers in where they go. B is 12, so you put 12 there. H is 8, so go ahead and put 8 there. And the nice thing with multiplying, you're taking 1/2 times 12 times 8. The nice thing with multiplying, as long as it's all multiplication, you can do it any order you want. In other words, I could take half of 12 and get 6, and 6 times 8 is 48. I could take half of 8 and get 4. 4 times 12 is 48. I could multiply these together first and get 96, and take half of 96 and get 48. Whatever way works easy. Whatever way works easiest for you. It's 1/2 times 12 times 8.
I
Half
didn't know
of.
you had to multiply that in half too.
The more you know.
Grayson, I would say you've learned one in this short class period than you maybe learned in the last 2 months combined.
Probably.
I'm tired.
That's okay, me too. Grayson?
13.
Grayson just starting to waste some time.
Oh.
Well, Grayson,
We can do
this is the key here. You're supposed to write it using exponents. So, how many x's are getting multiplied there? So that's x squared. How many y's are getting multiplied there? 3. So it's y. How many z's are getting multiplied there?
have to do it multiple ways.
That's it.
Oh, that's all the ways to do this. I have all the sides. I got so many.
Let's look and see.
We still don't have
6, 7.
17,
6, 7, 8, 9.
We don't need 6 and 7.
No, but I still want them. It's literally all this.
We do 6 just to get the notes. Yeah, we want the notes.
And 7.
Yeah, we'll get the notes for 6 and 7.
And
In case you're interested, I suppose number 6, just make sure you know that the square root sign is a symbol of inclusion. It's a, you have to do this first, so you can't, you have to do this before you take its square root. 25 minus 16 is 9, and the square root of 9 is 3. Here you do each of these separately. 5 minus 4, square root of 16, and that's why 3 is greater than 1.
Yes.
Alright.
I'm not sure, do I have to do this?
You don't even have to do notes.
This one is
No.
minus 1/4.
There's not even notes for that.
I know.
It's obvious.
Yeah, that's what I got wrong, because it doesn't look like the.
He literally told the entire class like
Okay.
800 times.
What, David?
Can I go to bands?
Yeah. Wait, just grab a test note off the line.
My bad.